In this module, we will discuss a very important part, operations on real numbers. Dear children, yesterday I had told you that this is a very important part. This is the base for many upcoming topics in your mathematics learning. Okay? So this is a simple thing what I expect from you all, that you will very nicely understand. That is why I had told you to write it down, all the things yesterday. Now, the very first thing that we are going to start, real numbers. We know real numbers are of two types, rational numbers and irrational numbers. You already know the operations of rational numbers: addition, subtraction, multiplication, division, right? Now what we are going to do? We are going to combine rational and irrational and see what happens. So right now on your screen, you can see the first thing what we are going to learn is addition. Right? Now addition or subtraction. Now you see children, you already know that addition and subtraction always go hand in hand. Now when I am speaking about addition of rational and irrational, okay? Now see, you can see here on the screen, on the board right now, very important point, a rational and an irrational number. I am repeating, a rational and an irrational number can never be added or subtracted. It remains as it is. So whenever you have a question of combination of rational and irrational, the answer will remain the question itself, the equation itself. So what we can see is that 2 plus root 5 remains 2 plus root 5 as it is. That means, see, this 2 is rational and this is irrational. We can never add or subtract them. It will remain as it is. I am repeating the point again and again. Rational and irrational, you cannot combine them. North pole and south pole, opposite side. You cannot. Just cannot do anything to them. Root 3 and 11. This is irrational, this is rational. It remains as it is. You cannot do anything. That is our point number 1. Addition of rational and irrational. Very quickly, we'll move on to point number 2. What you can see right now on your screen, number 2. So the second part, I need not explain anything. You already know the addition property of 0. 0 added to anything does not make any change. So 0 plus root 5 will be root 5 as it is, or 0 subtracted from anything also doesn't make any change. It's very easy to understand. Now mind well, addition of this rational and irrationals. Addition is always going to be irrational, addition or subtraction. Only in one case, addition is compulsory irrational. For rational and irrational, addition is always irrational. Subtraction is also always irrational. But just see, root 3 minus root 3, irrational minus irrational. But root 3 subtracted from itself is going to give us the answer 0, which is our most special rational number. That means addition of rational and irrational is always irrational. But the subtraction, again always irrational, only irrational subtracted from itself will give us the rational answer. So this is our rule number 1. This is what will come as a MCQ question, one-liner question. You should be very aware about these properties. Very quickly, we move on to our next property. Now this is a very important point. See, it was up till now two points we had seen, rational and irrational. Now it is irrational and irrational, and this is very important to understand. Children, we make mistakes over here only. Now, very important, the like irrationals can be added. Think very wisely and nicely over here. Like terms, just as we could add x plus x. X plus x was 2x. Similarly, root 5 plus root 5 is 2 times root 5. Any number taken twice, 2 times taken, root 5 taken 2 times. Correct? X plus 7x. What was the answer? 8x. Similarly, 1 time root 3 plus 7 times root 3 is going to give me 8 times root 3. Are we understanding? So like terms, like irrationals can be added or subtracted. So 4 root 7 minus, again the same thing, 4m or 4x minus 6m. 4m and 6m are like terms. 4m minus 6m was minus 2m. Similarly over here this would give you minus 2 times root 7. But as we couldn't add or subtract, unlike irrationals, that is again, let me write here 4x minus 7y, or this was x, so this is root x, so let it be 4x minus 7y. You cannot do anything, so this will also remain as it is. You just cannot add 4 and 7 and root 7 and root 4. No. Unlike irrationals, you cannot do anything. Let me take one more very quickly example over here. One more example. Root 7 minus root 5. What do you think should be the answer? Root 2? No, this is wrong, because unlike terms you cannot do anything. So root 7 minus root 5 कुछ नहीं हो सकता. Root 7 minus root 5 remains root 7 minus root 5. Just add, as I told you, addition or subtraction is not possible. Or root 7 plus root 5, can you add it as root 12? No, never. You can never add them, because they are unlike. They are unlike. Root 7 will add only with root 7, or root 5 will add only with root 5, not with any other root. And that too, root 7 plus root 7 would give you 2 root 7 and not root 14. This irrational part, you know that it is undefined, not terminating and not recurring. You don't have the answer, so you just cannot add. But 2 times the same number, so 2 times root 7. Understand very carefully. Unlike irrationals, cannot be added or subtracted. Only like irrationals can be added or subtracted. That too, only the coefficients, not the irrational part. So this is all about addition and subtractions of real numbers. Very quickly we are moving to the product, which is very interesting and easy again. So yes, the product of rational and irrational, again, just as we used to multiply. Now this is a simple thing. We have taken, for example, monomials. Just as we used to multiply, how it was, see, do you remember? It was coefficient into coefficient, variable into variable. See, if I would have given you an example, 3m into 2n. What you used to do? 3 into 2, m into n. You used to write 6mn. Do you remember? It used to be like this, 3 into 2, m into n. We used to multiply coefficient and coefficient, variable and variable. So which would give us 6mn. Similarly, 2 into 1, root 5 means what? 1 root 5. We know that. So 2 ones are 2, root 5 remains root 5. Or 3 into 7, rational into rational, irrational into irrational, coefficient into coefficient, variable into variable. So 3 into 7, 21, root 3 into root 2, root 6. So just as we used to multiply. Multiplication is easy. See, very important. Root 3 into root 2 is possible as root 6. But root 3 plus root 2 is not possible as root 5. Do you understand? Unlike irrationals, multiplication is fine, addition not allowed. Keep this point as a marked point. Write it down. You have not done it. Write it down. Unlike irrationals, can be multiplied, but unlike irrationals, cannot be added. So this is about the first part, rational and irrational multiplication of monomials. Quickly, what we see is that product of the 0, and you already know, just as 0 added to anything did not make a difference, similarly 0 multiplied to anything makes the product itself as 0. We know that. So this is not a major thing to be understood, but you know that 0 into anything is 0. Product of 0 with anything is going to be 0. We know that. It is very easy to understand. It is not an important or not a difficult thing. You can do it very easily. But again, it is very important. I said 0 plus root 5 will give me root 5, which was an irrational number. But 0 into root 5 gives me 0, which is a rational number. Do you understand, children? It's very easy. This was the additive identity. This was the multiplicative property of 0. We all know this, right? But just apply it very, very carefully. Let us move on to our next slide. What you can see on your screen is now is product of irrational and irrational. And now children, see, it's very, very important. Multiplying two irrationals. It's very easy. You can see now, I had just now told you that multiplication of unlike irrationals is possible, like irrationals is also possible, but addition only of likes was possible. Root 3 plus root 7, we didn't have answer, it remained root 3 plus root 7, but root 3 into root 7 becomes root of 3 into 7, that is root of 21. Correct? So these get multiplied but cannot get added, just as it was in algebraic terms. X into y gave us xy, but x plus y used to remain x plus y. So remember these things, okay? We already know all these things. Similarly, 3 root 5 into 2 root 11. Again, number with a number, irrational with irrational, rational with rational, irrational with irrational, coefficient with coefficient, variable with variable. 3 into 2, root 5 into root 11. 3 2s are 6, root 55. Multiplication is easy. Just apply yourself, children. It's very, very important. And later on, when you will be solving, you will combine all these rules. Okay, rules of addition, rules of multiplication. There you should not get confused. What is important? You should understand this. Okay, stepwise. You will follow this. Simple questions you will solve. Once you are solving the simple operations on real numbers, then the complicated ones become very easy because you are going to need them again. Similarly, root 11 into root 11 becomes root of 11 into 11. That is root of 121, which is again 11. So root of any number, root a into root a becomes a. This is what we are going to learn. And remember, we are going to use this again and again later on. So product of irrational and irrational sometimes will be irrational, sometimes can be rational. That is what we have already written on our screen. You can check it out. Understand carefully. The next part, what we are seeing is again product of irrationals, but the binomials. And children, we have already learnt the few properties like distributive properties or applying the identities. Last year we had done. One example we have taken, see, it's for the binomial into binomial. So how do we multiply? First term into bracket plus or minus second term into bracket. You can see right now on your screen, we have seen it how we have multiplied first term with the bracket, second term with the bracket, and ultimately slowly and steadily we have solved. We got the final answer as 3 root 10 plus 10 plus 6 root 22 plus 4 root 55. And you can see root 10, root 22, root 55. All are unlike terms. We just cannot add them. Correct? So the unlike terms remain as it is. Very next example, what you can see is that we can see root 5 plus 2 root 11 the whole square. It's about the identity. You have used the a plus b the whole square identity, a square plus 2ab plus b square. So first term square, 2 multiplied by first term, second term, and second term square. So again 49 plus 4 root 55, final answer. Or the third thing what you can see is that a plus b and a minus b, that you can do by a square minus b square. So you can use all these properties, just simple multiplication properties of algebraic expressions. Moving on very quickly, we move to our next part, last part, that is the divisions. So when we look about the divisions are again simple. See, again I am repeating myself. Additions of unlikes was not possible. Multiplication and division, addition and subtraction was not possible. Multiplication and division is always possible. You can bring them under the same roof. You can combine them. So 9 divided by root 7, but here it was totally different. Rational and irrational. So rational remains rational, irrational remains irrational. Ultimately this is the irrational number. Okay. But when both are roots, you can combine them. Just as it was multiplication, same for division. And root 14 upon root 7, 7 ones are 7 to the root 2, which is irrational. You know root 2 is irrational now, right? Or root 18 divided by root 2, 2 ones are, 2 nines are 18. Root 9 is 3. So division may be irrational or rational, just as multiplication was irrational or rational. If you remember, if it was root 3 into root 7, it was root 21, which was irrational. But root 11 into root 11 was 11, which was rational. So multiplication and division may sometimes be irrational, sometimes be rational. And then 0 divided by anything is 0. We again know this part very, very nicely. So moving on, just now what you can see on your screens is that we are going to write these rules. Now try to relate what we have understood, what we had learned. See, addition or subtraction of non-zero rational and irrational was always a irrational number. Then moving ahead, like terms were added and unlike terms we could not add or subtract. Next rule what we said, non-zero rational and irrational will remain irrational. 2 into root 3 is 2 root 3, totally irrational number. Next rule, irrational and irrational, sometimes rational, sometimes irrational. Multiplied with itself, root 11 into root 11 gave us 11, which was a rational number. Next rule, and the last rules about the ratios what we had seen. The ratios is sometimes rational and sometimes irrational. So that's all children about the operations on irrational numbers. I'll be giving you a few sums to solve, but before that, all of these things whatever we have learned, understand them very, very nicely. Carefully apply the rules, the simple rules of algebraic expressions, get your answers. That's all for the operations on real numbers. We'll be solving the sums on that. Thank you.